Ordering decimals is easily done if we have number sense. Comparing numbers is more easily understood if we think about the place value of a number. In our first example, we're actually using base 10 blocks, which help us look at which one is more. Compare 3 and 1500ths and 3 and 2/10. Which of these would be more? 3 is a whole number, 1/10 and 5/100ths. Remember that we call these tenths because it takes 10 of them to make a whole. We call these hundredths because it takes 100 of them to make a whole. 3 and 1500ths compared to 3 and 2/10ths. Hopefully you're able to look and see because this one has 2/10ths, it has a larger value than this one, 3 and 1500ths. We would say 3 and 1500ths is less than 3 and 2/10ths. Perhaps visualizing our base 10 blocks will help you compare numbers. Perhaps thinking about our money system and coins and bills will help you compare numbers. If you look at our place value chart, everything to the left of the decimal can be represented with bills, whole dollars and $10 bills and $100 bills, etc. Everything to the right of the decimal is part of a whole. That means that everything to the right of a decimal, you have to have 10 or 100 to make a whole. So if we are using money, then we're going to call this $99 and 6 cents, 6/100ths, 6 pennies. Because it is 2 digits after the decimal, we're going to call it hundredths, or for our example today, pennies. This says $99.06, which if you look 1 digit after the decimal is 6 dimes. So then which is bigger, $99.06 or $99.06, which would be equal to 60 cents? Thinking about it like money tells us that this one, $99.06, is less than $99.60. Comparing here, $133.23 compared to $133.02. This says 23 cents, this says 2 dimes. If I put that extra 0 to make it what we think of as a money amount, I'm then comparing 23 cents to 20 cents. This is the smaller one, this is the larger one, and we connect the dots to correctly draw our sign. 9 and 875 thousandths compared to 9 and 89 hundredths. If I use my place value chart, I know this is dimes and this is pennies, but what would this be? Well, if you look here, beyond the penny, we can think of it as non-cents, because we don't have a coin that it takes 1,000 of to make a dollar. So these are part of a penny. This is indeed a tenth of a penny. We call it a thousandth because it takes 1,000 of them to make a dollar. Sometimes in class we might refer to it as pocket lint, because indeed if we cut a penny into 10 pieces and tried to carry them in our pocket, when we reached in to get our tiny coin, we would probably get pocket lint. So this we could call $9.87 and a little bit more, compared to $9.89. So this one is the less than this one. $49.32 compared to $409.32. Our whole number is larger in this number, which means that it is indeed greater than this one. So I have my less than sign because the less than number came first. All right, perhaps you'll need a different strategy if you're comparing more than 2 numbers. This is a list of numbers and our directions are to put them in order from least to greatest. A strategy that will always work is to put them in a place value chart. In this case, I may have my decimal here and put each of these numbers in my place value chart. So 1 whole, 4/10 and 1/100th compared to this number, compared to this number, compared to this number. Now, the strategy that's most important at this time is that you're going to go all the way to the left. And when you're all the way to the left, you're going to see that the whole numbers are the same. So move to the tenths column. And in the tenths column, you've got some numbers that are different. Another strategy that you could use to help you is to go ahead and fill in zeros so that all of our numbers have the same amount of digits. So looking here, I can see that the smallest tenth is the 1. So 1 and 145 thousandths would be my smallest. My next number would be 1 and 356 thousandths. And now I'm comparing 40/100ths to 4/10ths. But because I added these zeros, I'm comparing 400 thousandths to 410 thousandths. All right, let's try it again here with 19 and 3/100ths, 19 and 3/10ths, 190 and 2/10ths, and 20. Again, decide where your decimal is going to be, and fill in your digits. Now, where do I put 20 in my place value chart? It is imperative that we remember there is a whole number, there is a decimal at the end of every whole number. Simply saying 20 refers to 20 wholes. So it would go here. And if I used my strategy of filling in additional zeros, and then going all the way to the left, it is absolutely simple to see that 190 and 2/10ths is my largest number. So I would start at the back because we're putting them in order from least to greatest. Now I'm in this next row and I'm comparing 2 1s and a 2 in the tens column. So that would tell me that 20 would go here. And then finally, ask yourself which is larger, 19 and 3/100ths or 19 and 30/100ths. So we've ordered our numbers from least to greatest using base 10 blocks, a money system, or a chart to line up your decimals and fill in your extra zeros. So now it's time to push pause and show what you know. Let's start by comparing 5 and 4/100ths to 5 and 4/1000ths. This says $5.04 versus $5.04, which means that your sign should be in this direction. $3.79 compared to $3.70 with 9 nonsense or 9 thousandths. So again, that one is larger. If I'm putting these in order from least to greatest, maybe I've put them all in my place value chart and I notice the whole numbers are all 49 and they all are at the thousandths. So I'm simply saying 302 thousandths, 203 thousandths, or 79 thousandths. Putting them in order from least to greatest would make this one first. 203 would be next, and 302 thousandths would be. Sue says that 8.71 is equal to 8.17 because they both have 3 digits. Explain her error. Hopefully you were able to tell Sue that the amount of digits doesn't matter as much as the place value matters. Where is that 7? In this one, she has 7/10ths or 7 dimes, and in this one, she has 7 pennies. So Sue was wrong because she didn't use place value.